Hello. Good morning, everyone. Hello. Just a minute. We'll wait for only 2 minutes. Today we'll see some points remaining from the fifth chapter, that is a circuit breaker. Okay. Just wait. I'll share the screen now. Hello. Hello. Uh, okay. So I think screen is now visible. Okay. So first, we'll discuss some points which we have seen in last lecture. So in last lecture, we have seen first the equation for this restriking voltage. Okay. So here we are considering one circuit and where the fault is occurring between two phases, means in a bus bar, and the circuit breaker is connected there. So here, how to calculate this restriking voltage? For that, we are using the Laplace's circuit. Okay, we are considering the Laplace's circuit, and from that we can obtain this voltage. Okay, so this voltage V of t is equal to Vm into 1 minus cos of omega t. Hello. So after that, we have seen the rate of rise of restriking voltage, that is the triple RV. Means we have seen the restriking voltage and how actually it is increasing. Means if the dielectric strength of these particles increases, then than the restriking voltage, that is nothing but the means that time this triple RV will also be more. Okay, and if it will decrease, means if the dielectric strength will decrease, then what is the effect on this triple RV? That is this triple RV is nothing but the rate of rise of restriking voltage, and remember it is measured in kilovolt uh, kilovolt per microseconds. Okay, so remember its unit also, and its value is depending upon the recovery voltage and natural frequency of oscillations. Now recovery voltage means when actually that arc is extinguished finally, that time whatever be the voltage appeared across the contacts of circuit breaker, that is nothing but the recovery voltage, and natural frequency of oscillations, which is noted by Fn. Okay, so this Fn is equal to 1 divided by 2 pi root LC. Okay, so this is the natural frequency of oscillations. Then we have seen the current chopping. Current chopping means what? Actually, at point 0, when we are considering any wave, the point 0 is there, where your current becomes 0. Okay, but in current chopping, what happens? So there are some equipments like, for example, when we are considering a transformer, and in transformer, when there are low magnetizing currents, so these currents are very low in magnitude, and what is happening when we are using the circuit breaker, what happens before that natural current is 0, when we are using circuit breakers for that, for example we are using the air blast circuit breaker, what happens, actually the current should become 0 at natural current 0 point, but due to that air blast circuit breaker, this current becomes 0 before the 0 point only. Before the 0 point only. So, because that air blast circuit breaker don't know where actually that current 0 interruption is there. Okay, so it is not checked by that air blast circuit breaker. It is continuously means that air is continuously forced on that arc. So mm, uh, it will not check whether that point means current interruption is at point 0 or before that. Okay, so means before point 0, that current becomes 0, and what happens due to that, the restriking voltage get increased there. Okay, so that is nothing but the current chopping. So these points we have seen uh, in last lecture. Okay, so here this is shown, uh, actually this is the natural current 0 point, and before that only this current 0 is occurred here. Then today we'll see the capacitive current interruption. So these are again the problems when we are using the circuit breakers. Whatever problems we are facing are these. That is, one more is the capacitive current interruption. Okay, so this is the cause of excessive voltage surges in the circuit breakers. Means what is happening due to current chopping also, there is a voltage surge, right? There is a voltage surge before the current 0 point only. Okay, before the current 0 point only, there is voltage surge. Means the voltage is increasing to the restriking voltage. So similarly in capacitive current interruption also, that voltage will increase. Okay, that is, it is the cause of excessive voltage surges. So for example, opening of an unloaded long transmission line. Okay, means suppose sometimes what happens when we are considering the long transmission lines, and that transmission line becomes unloaded, means load on that line becomes 0 or very low, or disconnecting a capacitor bank used for the power factor improvement. Okay, And if sometimes the capacitor bank get disconnected, okay, that time this voltage get that voltage get increased there. Okay, so here we are considering one circuit uh, for a transmission line where we are not connecting any load. Okay, so this is the circuit. Here Vg is the generator voltage, then L is the inductance, and this AB is your circuit breaker. Means A and B are the points, and VR is the voltage across this circuit breaker. Okay, across this circuit breaker means when actually this get disconnected, circuit breaker is having previously the close contacts. Okay, after some time they get open, means when the fault will occur, these contacts get open there. So when these contacts open, that time whatever be the voltage across the circuit breaker is nothing but the VR, and that is the difference between these points A and B. Okay, that is the difference between points A and B, and this capacitor C1 is connected across this supply. Okay, so here in every circuit, L and C will be present. So this C, the capacitance is for which power compensation? This capacitor C is used for the reactive power compensation. Okay. So here, in this, we are considering one equivalent circuit. So such a line, although unloaded in the normal sense, will actually carry a capacitive current I. Okay, means when we are considering such a transmission line, okay, when we are considering such a transmission line, and if that line is unloaded, means we are not connecting any load, in the normal case, it will have the capacitive current. Okay, means if no any load is connected, then it will have the capacitive current, because we know that capacitor stores energy, right? So that capacitive current will flow through that on account of appreciable amount of capacitance C between the line and earth, right? Because the capacitance is there and it is storing some energy, so whatever be that energy stored will be there of the capacitor. So due to that, the current will flow through that line, and that is nothing but the capacitive current. Okay, so all of you understood, when your line is unloaded, that time actually the load current will not flow there, but as there is capacitor, so the capacitive current will flow. Now let us suppose that the line is opened by the circuit breaker at the instant when capacitive current is 0. Now suppose that the capacitive current is 0, when the capacitive current is 0, and at the same time your circuit breaker contacts are open. Okay, the line is open by the circuit breaker. Okay, means as the circuit breaker contacts will open, your line will also be open, and at that time the capacitive current is 0. So here it is showing the point 1 in this figure. Okay, so here your capacitive current is 0, means your line is open. Okay, so when the line is open, you can see here this voltage. Okay, this voltage, when this current becomes 0, this voltage is VGM. Okay, means it reaches to the maximum value. Okay, so we'll see that. So here at this instant, the generator voltage VG will be maximum, that is VGM lagging behind current by voltage by 90 degree. Okay, so here this voltage becomes more there when your capacitance C is capacitive current is equal to 0 there at this instant. Then the opening of line leaves a standing charge on it. And the capacitor C1 is charged to VGM. Okay, means what happens? So when that line zero that time, and the voltage, your generator voltage becomes to the maximum, that is VGM. And when this line will open, when the line will open means when the circuit breaker contacts will open, that time only your line get open. It is leaving a standing charge on it, means there will be some charge on that line, and the capacitor C1 is charged to VGM. Okay, so at that time your capacitor C1 will charge. Okay, will charge to VGM, means to the maximum generator voltage. Okay, now however the generator end of the line continues its normal sinusoidal variations. म्हणजे काय होते, जेव्हा C1 म्हणजे कॅपॅसिटर जेव्हा तुमचा चार्ज होईल अप टू द मॅक्सिमम व्होल्टेज ऑफ जनरेटर, that time that time the generator end of line, okay, generator end of line continues its normal sinusoidal variations, means still your line is disconnected, still your line is disconnected, but it is supplied from the generator only, right? Yeah, here you can see here when the circuit breaker will open the contacts, when the circuit breaker will open the contacts, what is happening? Actually the charges will be there. Okay, charges will be there uh, on this transmission line. Okay, and this will this will charge the capacitor to the maximum voltage of the generator. And when this is disconnected, okay, when this is disconnected, when this circuit breaker will operate, that time uh, this generator will supply this line also. Okay, that generator is supplying the line, but what is happened, this up to point A only. Okay, up to point A only the generator will supply. Now from point B, your line is disconnected, right? From point B your line is disconnected, and when this line will disconnect, whatever be the charge on that, so due to that your capacitor get charged there. Okay, your capacitor gets charged. So the voltage VR across the circuit breaker will be the difference between the voltages on the respective sides. Okay, now what I told you, that here what is happening, up to point A your generator is supplying, and uh, uh, from from B that line is disconnected, right? So that charge that capacitor, so its voltage is up to the maximum voltage of this generator, right? So what is happen here, some voltage will be there across this capacitor, and the voltage will be there across this generator also. So whatever be the difference of that voltages will be appeared across this circuit breaker, right now, across this circuit breaker, and that voltage is nothing but VR. Okay, that voltage is nothing but VR. VR means what? VR means what? So when any fault will occur, that time your circuit breaker will operate. Actually the contacts of circuit breaker are closed, so when the fault will occur, the circuit breaker contacts get open here. So when these will open, the generator voltage will be supplied up to point A only, and the remaining voltage of across this will be the voltage appeared across the capacitor only. So whatever be the difference between these two lines is nothing but the voltage VR. Okay, so the voltage VR across the circuit breaker will be the difference between voltages in respective sides. So its initial value is 0. Its initial value is 0 and increases slowly in the beginning. Okay. So why its initial value is 0? Why its initial value is 0? Because when the circuit breaker contacts are closed, that time whatever be the supply voltage, that is the generator voltage, is nothing but the voltage across this capacitor, right? Across this capacitor. समजतंय का सगळ्यांना? Yes or no? Is all of you getting or not?
Yes, no.
Okay. So when the circuit breaker contacts are closed, that time whatever be the voltage across this generator is equal to the voltage across capacitor. This is simple. You have studied in all subjects, especially in network, right? But when this will disconnect, means when your circuit breaker will operate, means this becomes open circuited. That time what is happening? The voltage difference will be there, means voltage across this generator, means this line will be different and voltage across the capacitor will be different, and that difference is nothing but your VR. And what happens at start? That difference is equal to 0 because your contacts are closed. But when you separate the contacts, that time the difference is slowly increasing. Okay, that difference is slowly increasing because your capacitor starts discharging, right? Right. That's why. Now, but half a cycle later, that is point R in figure, the potential of the circuit breaker at contact A becomes maximum negative, right? So at this point R, okay, at this point R, this potential difference becomes maximum negative. Okay, maximum negative at this point R. Means what happens? Can anyone tell me? Okay, it becomes maximum negative, which causes the voltage across circuit breaker VR to become 2 VGM. So can anyone tell me what is actually occurring or happening? Yes. So what is happening when we are now disconnecting? When we are disconnecting these 2 points, this voltage, okay, and now there is no any load connected, right? No any load connected. So this voltage becomes more. Okay, this voltage becomes more and it becomes up to 2 VGM. Okay, but it is in negative. So here point R is shown. So the total voltage becomes 2 VGM here. Okay. Then this voltage may be sufficient to restrike the R and the 2 previously separated parts of circuit breaker will now be joined by an arc of very low resistance. Okay. Now after separating these contacts, the arc will be struck between these 2 contacts. Okay. Between these 2 contacts, and what is happening? Again, there will be flow of current. Okay. There will be flow of current as there is an arc. Right. सो पहिल्यांदा काय होतं, आपण सर्किट ब्रेकरचे कॉन्टॅक्ट ओपन करतो. ओपन केल्यानंतर आर्क डेव्हलप होते. पण इथे काय होते, ऍक्च्युली जो नॅचरल करंट 0 पॉइंट आहे, त्या नॅचरल करंट 0 पॉइंटच्या आधी इथे, ओके, here only your difference between the potential starts increasing. Okay, it starts increasing at point 1 only. Okay, at point 1 only. So hello. So if the gap, okay. So if the gap breakdown strength does not increase rapidly enough, okay, so the successive restricts can build up a dangerous voltage in the open circuit line. So what is happening? So if means that uh, means such breakdown uh, means that the arc should be break there. Okay, so uh, means if the dielectric strength of that gap means of that particles uh, is becoming more and more, then we are not able to just break that arc, right, or extinguish that arc. So again it will restrike. Okay, again it will restrike. So if it happens continuously, so it will reach to a dangerous voltage. Means already we have seen the voltage of the generator was vgm, and when continuously restriking is happening, that time that voltage is increased up to 2 vgm, right? So uh, that voltage will and if again it will restrike, again the voltage will increase, so it is dangerous to the system. So however, due to leakage and corona loss, the maximum voltage on the line in such cases is limited to 5 VGM. Okay. So by considering the leakage and corona losses, the maximum voltage means this is the set point. That set point is kept at 5 VGM. Okay. So this is the maximum voltage that can be beared by the line. Okay. So this is the current capacitive current interruption, and we have first seen the current chopping and capacitive current interruption. Okay. Now the next point is resistance switching. So in this resistance switching in circuit breakers, here again you can consider a line. Okay, here the supplies E, inductor, capacitance are connected in parallel. Now circuit breaker is there, and what we are doing here, again we are considering a short circuit fault, right? But a resistance R is connected across this circuit breaker. Okay, so resistance switching in circuit breaker refers to a method adopted for dampening the over voltage transients due to current chopping and capacitive current breaking. So we have seen that what is happening when there is current chopping or capacitive current breaking is there. So what is happening? The transients are produced. Means that voltage is reaching to the maximum value when the current becomes zero. Means the transients are there. Okay, transient restriking voltages are there. So to reduce these voltages, okay, to reduce these voltages or for dampening, डॅम्पनिंग माहिती आहे ना कंट्रोल सिस्टीम मध्ये? येस ऑर नो? Yes. What are the types of this dampening? माहिती आहे की नाही? हॅलो. Hello, anyone? What is mean by dampening? Aditya, Deepak, Suvarna. What is mean by this dampening? Jasin, critical damping, etc. Have you seen that? Studied?
Yes, ma'am.
Yes. Right. Okay. So here the dampening means what? Actually, what is happening when we are considering the restriking voltage, right? Restriking voltage. Just a minute. So that restriking voltage is here, right, on this way. So when you've seen that there are transients, right? So that voltage is decreasing there. That voltage is decreasing there, but that is not a pure sine wave, right? Right. So dampening is there. Dampening is there. So what we have to do when the dampening is there? So to make this wave constant, right, means to decrease this transients or to remove these transients, we have to do something. So what is the method? So this is nothing but the resistance switching. Okay. म्हणजे हे ट्रान्झिएंट्स जे येतात जेव्हा तुम्ही रिस्ट्रायकिंग व्होल्टेज कन्सिडर करता तर रिस्ट्रायकिंग व्होल्टेज मध्ये दाखवताना तुम्ही बघितलं असेल ही जी वेव आहे ही कम्प्लीट साइन वेव नव्हती तर तिथे काय होतं डॅम्पिंग. ओके म्हणजे ट्रान्झिएंट्स होते. ओके ट्रान्झिएंट्स होते तर ते आपल्याला काय करायचे तर आपल्याला कंटिन्युअस म्हणजे ते डिक्रीज करायचे ते ट्रान्झिएंट्स काय करायचे रिमूव्ह करायचे किंवा डिक्रीज करायचे सो दॅट वी कॅन गेट ए continuous supply there. Okay, so we are using here the resistance switching method. So in this method a shunt resistance is connected across the contacts of circuit breaker, right? So here we are connecting one resistance in parallel with the circuit breaker. Okay, now working of this resistance switching. So because of the occurrence of fault, when the contacts of circuit breaker will open and arc will be struck between the two contacts, right? So when any fault will occur, so when we open these two contacts, then the arc will be produced between these two contacts. So since the contacts of circuit breaker are shunted by resistance, therefore a part of the arc current will flow through the resistance arc, right? Means when any fault will occur and when the contacts of the circuit breaker will open, actually when the contacts will open still there is an arc, right? Means still the current is flowing through the contacts of the circuit breaker, but when we are connecting one resistance R, some current, this fault current will flow through this resistance R also, right? Actually the current is flowing through this circuit breaker contacts also, but when we are connecting this resistance R, so current will flow this resistance R also. Okay. So due to this, the magnitude of arc current will reduce, which in turn will result in increase in rate of deionization of arc path, and in this way the arc resistance increases, right? Simply. So when the current flowing through this arc will decrease, means the contacts of circuit breaker will decrease, because the actually when we were not connecting this resistance R, total current was flowing through only the circuit breaker contacts, means through the arc only. Arc is between this arc only the whole current was flowing. Now what we are doing? We are connecting one resistance. So whatever be the current flowing through that arc, that is splitted here. Some current is flowing through the arc, some current is flowing through this resistance R, right? So when the current will flow through the resistance R, what will happen? The current from this side, means current which is flowing through this arc is decrease. Is decrease means these particles, there are number of ionized particles, right? Arc is nothing but the number of ionized particles are there, and these ionized particles get decreased. The number of ionized particles get decreased there when we are connecting one more resistance in parallel with it. Okay, so when the number of ionized particles will decrease, means the current flowing through this arc decreases. So what about the resistance of this arc? What will be the effect on resistance of arc? Yes, anyone? Hello, what is the effect on resistance of arc? Resistance will decrease or increase? Arc resistance will increase. Correct. Arc resistance will increase there. Okay, so arc resistance increases, and this cumulative process will continue till the magnitude of current becomes too low and it is not able to maintain the arc. म्हणजे ही प्रोसेस काय होणार आहे? कंटिन्यू राहणार आहे. So after some time, what happens? That arc resistance will increase, means whatever be the current flowing through that arc will decrease, means that arc will completely deionize. Okay, so means that current becomes too low, that it is not able to maintain that arc. Okay, so the arc extinguishes, means your arc will break there or extinguish there, and the current is interrupted by the breaker. Okay, so now here the resistance switching also reduces the oscillatory growth of restriking voltage. ओके, म्हणजे जे ट्रान्झिएंट्स प्रोड्यूस होतात, म्हणजे जे ऑसिलेशन्स प्रोड्यूस होतात, तर ते पण डिक्रीज करते. दॅट इज रेजिस्टन्स स्विचिंग. अँड द नॅचरल फ्रिक्वेन्सी ऑफ दिस सर्किट is given by Fn is equal to 1/2 pi square root of 1 divided by LC minus 1/4 R square C square. So remember this equation. And the main role of shunt resistance is to limit the growth of free strike voltage and cause it to grow exponentially up to recovery voltage. Okay, means what is that shunt resistance is doing? It is limiting the restriking voltage. Okay, and cause it to grow exponentially, means it will grow exponentially. Exponentially means whatever be the transients are there, that will be removed. Okay, म्हणजे हे जे ऑसिलेशन्स होते ते काय होणार आहेत? रिमूव्ह होणार आहेत. सो देर विल बी, मीन्स इट विल increase exponentially up to the recovery voltage. And if the value of resistance is so selected that the circuit becomes critically damped. Okay, म्हणजे अशी व्हॅल्यू रेजिस्टन्सची कनेक्ट करायची की सर्किट कसं होईल? क्रिटिकली डॅम्प. देन रिस्ट्राइक व्होल्टेज राइजेस एक्सपोनेन्शियली टिल रिकव्हरी व्होल्टेज इज रिच्ड. ओके, म्हणजे क्रिटिकली डॅम्पिंग मध्ये काय होतं? तुमचं म्हणजे जे सगळे ट्रान्झिएंट्स आहेत ते सगळे रिकवर झालेले असतात, ते सगळे कमी झालेले असतात. ओके, तुमची आधी ट्रान्झिएंट्स असताना असं असतंय बरोबर. आणि क्रिटिकली डॅम्पिंगच्या वेळी दिस इज युअर कंडिशन, राईट. दिस इज युअर critically damped condition, means all these transients are removed there. Okay, so we have to select such a value of that resistance so that your voltage will not be oscillatory, so it will rise exponentially. Okay, till the रिकव्हरी व्होल्टेज इज रीच, म्हणजे इथून पुढे तुमचं रिकव्हरी व्होल्टेज स्टार्ट होते बरोबर. सो अप टू दिस दॅट रिकव्हरी व्होल्टेज that restriking voltage will be critically damped or it will increase exponentially. Okay, now the value of R for critical damping can be found as 1 this is 1 upon LC minus 1 divided by 4 R square C square is equal to 0. So if we take this to the right side, so here 1 divided by LC, 1 divided by 4 R square C square. So this C get cancelled here. So it is 1 divided by L is equal to 1 divided by 4 R square C. So if I cancel 1 also here, so it will come in the numerator, means L is equal to 4 R square C here, right? So this R square is equal to L divided by 4 RC. So we can take the square root and you can find the value of resistance. Okay, means here to reduce these oscillations, we can find the value of resistance. Okay, here as a 0.5 square root of L divided by C. Okay, means if you connect this value resistance, okay, if you connect this value resistance, then that voltage will rise exponentially, means the transients will be reduced there. Okay, समजलंय सगळ्यांना? Yes or no? Resistance switching. Simply here we are connecting one resistance in parallel with the circuit breaker. Okay. Now there are some advantages of this resistance switching. इथे दिलंय बघा. So here what is happening? Voltage here is our current 0, right? So when this current 0 is there, actually the wave is shown. So our wave is sine wave. So when that voltage is becoming or increasing to the maximum value, what is happening? That restriking voltage is also maximum, but that is oscillatory, right? So this is oscillatory restriking voltage, and after that it recovers. Okay, recovers म्हणजे काय होतं? ते सप्लाय व्होल्टेज एवढं होते. ओके, अप्रॉक्सिमेटली सप्लाय व्होल्टेज एवढं होते जेव्हा आर्क कम्प्लिटली एक्सटिंग्विश होईल तेव्हा. ओके, रिकवर होतं व्होल्टेज, पण रिकवर होतं. पण पहिल्यांदा काय असतं, जेव्हा तुम्ही कॉन्टॅक्ट ओपन करता त्यावेळी करंट म्हणजे ऍट पॉइंट 0 करंट 0 कॉन्टॅक्ट सेपरेट केल्या व्होल्टेज कसं असते? ऑसिलेटरी. ओके, दॅट इज द रिस्ट्रायकिंग व्होल्टेज. मग हे काय करायला पाहिजे आपल्याला? तर त्यासाठी आपण काय प्रोव्हाइड करतोय? तर एक रेजिस्टन्स इन पॅरलल विथ दॅट सर्किट ब्रेकर, सो दॅट द ऑसिलेशन्स कॅन बी डिक्रीज अँड युअर वेव्ह विल बी द साइन वेव्ह ओनली. म्हणजे हे जे ऑसिलेशन्स आहेत ते काय होतात? तर डिक्रीज होतात. दॅट इज द डॅम्प restriking voltage will get. So the advantages of this resistance switching are: first is it reduces the rate of rise of restriking voltage and the peak value of restriking voltage. So it will reduce the triple RV, means rate of rise of restriking voltage. Means what is happening? restriking voltage already we are getting, but due to that current chopping and that oscillatory current interruption method, so again this again there is a restriking. Okay, again there is restriking. So due to that continuously restriking, now the voltage reaches to the maximum level again, 2 vm, 3 vm, etc. So we have to reduce that rate of rising the restriking voltage, so which is reduced by the resistance switching method, and the peak value of the restriking voltage, okay, means the maximum value of restriking voltage is also reduced, rate is also reduced, and peak value is also reduced. Okay, and second advantage is resistance switching helps to reduce the voltage transient surge during current chopping and capacitive current breaking. So it is reducing the transient surges. म्हणजे as we have seen this, these transients are also reduced by using this resistance switching. Okay, so समजलंय का सगळ्यांना? Yes or no? समजलंय का? Yes or no? Okay, now we'll see some examples, and then our chapter will be over. Just let I minimize this. So everyone just note why whatever I'm writing here. So write down example. A 50 hertz 11 kV, a 50 hertz, comma 11 kV, three phase alternator, with earth neutral has with earth neutral has a reactance of 5 ohms of 5 ohms so 5 ohms per phase, and is connected to it's connected to a bus bar through a circuit breaker. Through a circuit breaker. The distributed capacitance up to circuit breaker between phase and neutral is between phase and neutral is 0.01 microfarad. Okay, microfarad. Okay, determine first frequency of oscillations. Frequency of oscillations. And second is the average rate of rise of rise of I'll write the triple RV directly. Which triple RV means rate of rise of restriking voltage up to the first peak. First peak. So everyone note and tell me how to solve. Okay. So if 50 hertz, 11 kV, a 50 hertz 11 kV three-phase alternator with earth neutral has a reactance of 5 ohms. Okay, reactance of 5 ohms. Okay, per phase. Reactance of 5 ohm per phase. Okay. 50 hertz means frequency F is equal to 50 hertz, right? 11 kV transmission, 11 kV three-phase alternator. Okay, R2 has a reactance of 5 ohms per phase. So this is your Excel only. It is 5 ohms per phase and is connected to a bus bar through a circuit breaker. The distributed capacitance of two circuit breaker between phase and neutral. Two circuit breaker between phase and neutral is 0.01. Capacitance C is equal to 0.01 microfarad. Determine frequency of oscillations. Okay. Frequency of oscillations, that is natural frequency, is equal to what? Then average triple RV up to first peak. Okay, up to first peak. Okay. Triple RV. RV. Average, it's average triple RV is equal to what? Now first they ask natural frequency. So what is formula? Fn is equal to it is equal to 1 divided by 2 pi root LC, right? 1 divided by 2 pi root LC. Now 2 pi square root of L is given, C, no, L is not given, XL they have given. So we have to find, and capacitance is given. So how to find C? Yes, how to find C? Capacitance C, sorry, how to find L? Yes, how to find L from the given data? Yes, how to find L from given data? Swapnil, Revati, Amruta. What is formula to find inductance L from the given data? This is from basic electrical. Shantanu. Yes, anyone? Vishal. आहात का लेक्चर मध्ये? Okay. So anyone? No one knows the formula to find inductance. Okay, what is formula of XL? XL is equal to, and what is formula for XC? 2 pi FL. Correct. And XC is equal to 1 divided by
C.
2 pi FC. Correct. So from that we can find the L, right? So here this XL is equal to 2 pi FL. 2 pi FL. So this L is equal to XL divided by 2 pi F. 2 pi F. So XL is 5, right, divided by 2 pi into 50. So find this L inductance 0.015. Okay. So what is unit? 0.015. What is unit for inductance? Inductance is measured in. Okay. Now we have to find here this natural frequency of oscillations, that is Fn is equal to 1 divided by 2 pi and root LC. So L is 0.015 into the capacitance. C is 0.01 microfarad. It's 0.01 micro. Micro means 10 raised to minus 6. Okay. So find this Fn first. So what is Fn? What is answer? किती आलंय? F N Hello. Are you solving anyone or not? Otherwise, you solve yourself. The value 8 आहे त्याची. Okay. So what is that value? It's almost okay. Uh, no. एक minute. So 0.15. 0.15 into 10 raised to minus 6. Okay, 1, 2 means 1 into 10 raised to minus 8. Okay, so just leave this. Okay, and 1, 2, and 3. 3. 1, 2, and 3. Correct. 15 into 10 raised to 10 raised to minus 3. Right. So this will be total 10 raised to minus 11. Right. 15 into 10 raised to minus 11. Just take the square root of this term. 15 into 10 raised to minus 11. Point. And then multiply by 2 pi. And now check. Sometimes in calculations also you may have the mistake. एक मिनिट मी पण चेक करते. Might go. येतंय का? Yes or no? कुठे येतं? येतंय की नाही? किती येतंय अंकिता? Ankita, what is your answer? Kishori, Payal, anyone else if you have solved? Check this. Anyone solving or not? Okay, I'll tell you how to solve the next point. That is average triple RV up to first peak. Okay, average triple RV up to first peak. Then, so for finding this average triple RV, there is again one formula. So the average triple RV is given by average triple RV is equal to peak restriking voltage is equal to peak restriking voltage peak restriking voltage divided by time, that voltage divided by time up to the first peak, up to the first peak. Okay, so here the peak restriking voltage, okay, peak restriking voltage, is that given? Peak restriking voltage is given or not? Peak restriking voltage is given or not? It is not given, right? So we have to find that and the time up to the first peak. Okay, so that also we can find. So first we'll find the peak restriking voltage. So this peak restriking voltage we have to consider the 2 Emax. Okay, because when your wave is again striking, means the maximum voltage is 2 Vm there, or we can say that it is a 2 Emax. Okay, 2 Emax. So that Emax can be found as this Emax is equal to Emax is equal to square root of 2 into now which voltage is first given? It is the phase 11 kV 3-phase alternator with a neutral. Okay, means RV. Okay, means we have to consider the phase to neutral. Okay, phase to neutral means it is line. Okay, it is line, and this VL is equal to V phase divided by root 3, right? divided by root. Sorry, eraser. Okay, so that line voltage is VL, that is 11 kV. It is given divided by root 3. Right. So this Emax will get you Emax. Then you have to find the two Emax, because this is the maximum restriking voltage. Right. So just find this two Emax. That is the peak restriking voltage you will get here. Then we have to find the time up to the first peak. Okay, time up to the first peak, and this formula is T is equal to 1 divided by 2 Fn. Okay, 1 divided by 2 Fn. So we already know this Fn, right? So first calculate that, and then just put the value here of Fn. Then you will get the time up to that first peak, right? And then you can find the average rate of rise of voltage, restriking voltage. So this voltage is in kilovolts. Okay, this voltage is in kilovolts, kV, and the time is in microseconds. Okay, because the unit of the triple RB is kilovolt per microseconds. Okay, so find this fastly. Then we'll see the next example. One more example we'll see. Okay, at least note the formulae and you can solve. Then I'll write one more example. Just a minute. Just a minute. Screen sharing. Okay, now screen is visible. Hello, is screen visible now? Okay, write down example. Next example. In a short circuit test, in a short circuit test on a circuit breaker, the following readings were obtained. The following readings were obtained on single frequency transient, on single frequency transient Hello. So, time to reach the peak striking voltage is given. So, the time to reach peak striking voltage is equal to 50 microseconds. Is equal to 50 microseconds. Then second is the peak striking voltage is 100 kV. Peak striking voltage is 100 kV. Determine the average triple RV. Average triple RV and frequency of oscillations. And frequency of oscillations. Okay. So, how to find this? Now here the direct data is given. So in short circuit test on circuit breaker, the following readings were obtained. Okay, the following readings were obtained on single frequency transient. Here on single frequency transient, the time to reach peak striking voltage. This time is given T 50 microseconds, and peak striking voltage is also given. Okay, so we have to find the average triple RV. So what is formula to find average triple RV? Average triple RV is equal to peak striking voltage, right? Peak striking voltage divided by time to reach the peak striking voltage, divided by time to reach this peak striking voltage. Peak striking voltage. Okay, so it is already given. Peak striking voltage is 100 kV, right? 100 kV, and the time is 50 microseconds, and it is given in whatever units we require. So the answer is simply 2 kilovolt per microsecond. Then second is frequency of oscillations, that is Fn. So this Fn is equal to 1 divided by 2 into time to reach peak value, into, or I'll write directly only the T, okay, into 2T. So it is equal to 1 divided by 2 into time is 50 microseconds. Okay, so it is 50 into 10 raised to minus 6 seconds. So it is 10 raised to plus 6 divided by 100. Divided by 100. Okay, means 10 raised to 4 will remain. Means it is 10,000. Okay, 10,000. So this Fn is equal to 10,000 hertz. Okay. So this is the answer. So such simple questions can be asked in examination. So remember the formulae for that. Okay. So in this way, our fifth chapter is over here. Again, 2 chapters are remaining, but these are small chapters. Both chapters will require 7 lectures here. Okay. So here our fifth chapter is covered. Circuit breakers. Now, next chapter is types of circuit breakers. Right? There are different types of circuit breakers. We will study in next chapter. So, any doubt? समझले again ना? Yeah, I think no one is present in lecture. Okay, no problem. So, do these calculations of the first example also. So all formulae are already given. You have to only calculate. Okay. So now we'll end the lecture here. Thank you all and have a nice day. Thank you.